Circle. Distance of points from centre. Example 1. Checking points. For the circle with centre at 2, 4 and radius r equals 5, check whether the points 2, 2, minus 6, 2 and 6, 1 are inside, outside or on the circle. So we'll start now with the point 2, 2. And the centre is at 2, 4. So the distance from 2, 4 to 2, 2 is just 2 units. There's no difference in the x, they're both x equals 2, and the y value, 4 minus 2, is 2. As the distance from 2, 2 to the centre of the circle equals 2, and it's less than the radius of 5, it therefore lies inside the circle. We could have also calculated this using the formula. Here's the formula for the length of a line segment. x1 minus x2 squared plus y1 minus y2 squared, all square rooted. This is the Pythagoras equation. Now where x1, y1 is the centre of the circle, it's 2, 4, and x2, y2 is 2, 2, the point of interest. Substituting into the equation, we get 2 minus 2 for the x1 minus x2 squared and 4 minus 2 for the y elements. That becomes 0. We get 2 squared. So it's the square root of 4, or 2. And because it's 2 and less than the radius, the point 2, 2 is inside the circle. We turn now to point minus 6, 2. We're going to calculate the distance between the points using the formula. Same again from Pythagoras. But in this case, x1, y1, the centre is at 2, 4 as before, but x2, y2, our point of interest, is minus 6, 2. So we're going to substitute these different values for x2, y2 into the equation. So substituting, we get x1 is 2, but x2 is minus 6. y1 is 4, and y2 is 2. So 2 minus minus 6, that's 8, that's squared. 4 minus 2, that's 2 squared. So we get 8 squared plus 2 squared, or 64 plus 4, or the square root of 68. Now the square root of 68 is approximately 8.24. But that's significantly bigger than the radius of r equals 5. So the point is considerably further away from the centre. So as the distance of point minus 6, 2 from the centre is roughly 8.24 and greater than the radius, it lies outside the circle. We now turn to the third point, the point 6, 1, and we use exactly the same formula as before. Our points here are 2, 4 for the centre of the circle and 6, 1, the new point of interest. In this case, x1 minus x2 is 2 minus 6 for here, and the y values are 4 minus 1, so 4 minus 1. So we get minus 4 squared plus 3 squared, or the square root of 16 plus 9, or the square root of 25, or 5. Now this answer is exactly the same as the radius. So the distance, the shortest distance from 2, 4 to 6, 1 is 5. It implies that it must be on the circle that has a radius 5. So as the distance from 6, 1 to the centre is 5 and it's the same as the radius, it therefore lies on the circle. So if we take the time to draw the circle, we would see that 2, 4 there, we draw the radius of 5. And if we were asked in the exam to draw it, we would see that 2, 2, the point, is inside the circle. Minus 6, 2 is outside the circle. And 6, 1 is on the circle. So a radius of 5. This is just a distance of 2. And this is greater than 5, about 8.24. So it's outside the circle.